In today's lesson, we're going to talk about manipulating formulas using square roots. So a major thing, and we're just going to jump right into it, a major thing that's going to occur here is that we're going to talk about those opposite operations. And what I mean by that is that we here in the top right know that plus and minus are adding and subtracting are opposite operations, right? Multiplication and division are opposite operations, right? And we can use, in this case, the square root and something squared are opposite operations. So we're going to use that fact a little bit, that the square root and the square eliminate one another. So we can think about this because we can use the fact that the square root of x, and this is something we previously learned, is that x is to the 1/2 power, really, right? We can convert between those two forms. They're equivalent to one another. So that being said, if we go ahead and square that, right? If we said, then we're going to square this, that would look like this squared. And using exponent rules for us, right? We use exponent rules and say power raised to a power means we multiply. 1/2 times 2 is just 1, right? X to the first is just x. So essentially, we can just jump straight to this step and say, look, the square root and the square can cancel each other out, and you're just left with your radicand. What's underneath is x. So we'll use that throughout this lesson. Let's take a look at the first one. The distance in miles that the lookout of a submarine can see is approximately given by d is equal to 1.22 times the square root of h. Okay, where h is the height in feet above the surface of the water. How far would the periscope have to be in the water to locate a ship 6 miles away? So this is asking d is equal to 6. We're going to solve for h. So 6 is equal to 1.22 times the square root of h. The first thing we're going to want to do is get the square root of h alone, right? We always want to try to isolate our variable regardless of what we're solving for, what's within our equation. So what I'm going to do is I'm going to divide by 1.22. Let's take a look and see in our calculators, what's 6 divided by 1.22? We never want to round mid-problem, so the fact that this gives us not a nice clean answer means that we're going to want to just keep it as 6 divided by 1.22 for now. All right? So I'm going to keep it 6 divided by 1.22 is equal to the square root of h. What we're going to do here is then square both sides. So just like we can add or subtract to both sides, we can also square both sides here. What that's going to do for us is that's going to get rid of the square root on the right side, and we're going to get h is equal to. Then in our calculators, we're going to plug the left side in. We can say 6 divided by 1.22, or you could use a fraction as well, but we're going to square that whole thing. We get this here, and it said in the instructions round to the nearest tenth. So the 1's going to be rounded to 2 because of the 8. So this is 24.2. So we have h is equal to 24.2 feet. Okay, so that means in order to see 6 miles away, the periscope has to be 24.2 feet high to see that distance. The voltage V in a circuit can be given by this equation here, where P is power, R is resistance. All right. So if the voltage of a circuit is 120 volts, so V is equal to 120, and the circuit produces 150 watts of power. Power is in watts, so P is equal to 1500. What is the resistance of the circuit? So we're going to try to find R. So we can use that equation and say 120 instead of V is equal to the square root of 1500 R, right? So in the last problem, we had first divided to get rid of that 1.22, right? But this time the 1500 is inside the square root. So what this is going to signify for us is that we want to get rid of the square root first. So if we square both sides, we can actually find what 120 squared is, and that will be nice and clean for us, 14,400. This will give us that 14,400 is equal to 1500 R, because on the right side, remember, the square and the square root cancel, and you just get exactly what's underneath. We then could solve for R by dividing by 1500 from both sides. And we're going to get R is equal to, so we're dividing that 14,400 by 1500. We get R is equal to 9.6. Resistance, it says, is in ohms, so this is 9.6 ohms. Remember to put your units here. We're talking about some word problem and application problems. Part B tells us suppose an electrician designs a circuit with 110 volts. So that's our voltage. Voltage is 110, V is 110, and a resistance of 10. So this time R is equal to 10. How much power, so P, we're trying to find, would that produce? So we'll set it up again. 110 is equal to the square root of P times 10, or you could have written 10P. So I'm still using that same exact formula up here from above. Pause the video now, try to solve for P. So you should have gotten this. 1,210 watts would have been the power that the circuit could produce. All right, so you should have squared it first to get rid of the square root. Since the 10 was underneath the square root, we can't divide by 10 before. We can't just divide by 10 to get rid of that, all right? So please make sure that you're squaring first to get rid of that. If the 10 was on the outside, we could have divided. Good. We're going to continue down here. To skip 3, we'll go to 4. We're going to take this kinetic energy formula, where K is kinetic energy, M is mass, V is velocity. We're going to solve the equation to find velocity. So to find velocity means we're going to solve for V is equal to, and then it says in terms of M and K, right? Because mass and kinetic energy was M and K. So let's rewrite the formula first, that we have K is equal to 1/2 mv squared. Let's get rid of this fraction. So the 1/2, the m, and the v squared are all being multiplied. We can get rid of fractions by multiplying by the reciprocal, so by 2/1 instead of 1/2. But that needs to be done to both sides. Yes, 2/1 is just 2, right? So this is 2k is equal to, on the right side, the 1/2 and the 2/1 cancel. This is k is equal to mv squared. I'm going to go one step further here. We're trying to solve for v, so the m is being multiplied to v squared. So I'm going to divide by m. And we get 2k over m is equal to v squared. To get rid of the square, right, it's the same idea as the square root, but this time, right, we had been squaring both sides. This time we're going to square root both sides. And the whole reason we're doing this is because the square and the square root cancel each other out, right? And on the right side, I'll go this way here, we're just left with v. And on the left side, we have the square root of 2k over m. We could talk about having to rationalize the denominator here. In this case, we're going to leave it like so, right? But hypothetically, I just want you to watch along with this. We could break that into the square root of 2k divided by the square root of m using our exponent rules or radical rules. To rationalize, we would have had to multiply by the square root of m over the square root of m. And what this would have ended up being is the square root of 2km divided by m, we would have said is v. So hypothetically, rationalize, this is what it would have been. But in this case, we're just going to leave it like so. Doyle's log rule estimates the amount of usable lumber in board feet that can be milled from a shipment of logs. It is represented by that equation there, where D is the log diameter in inches, L is the log length in feet. Suppose a truck carries 500 feet of logs. All right, so it says L is equal to 500. All right, because it's saying the length, L is the log length in feet. And that the shipment yields a total of 6,000 board feet of lumber. All right, so that's B, right? This whole equation here says that we have 6,000, in this case, board feet of lumber. Estimate the diameter to the nearest inch. So we're going to say diameter is equal to what? That's what we're solving for, right? We're assuming that all the logs in this case have the same diameter, or I guess you could look at it like we're solving for that average diameter in this case. So we plug these numbers in first. So we get 6,000 is equal to 500 times D minus 4 divided by 4 quantity squared. D is what we're trying to solve for. So I would start this off by dividing by 500. So we want to get the piece that's squared alone. So if we divide by 500, we get rid of the 500 on the right side. And on the left side, what we're going to get is 12 is equal to D minus 4 divided by 4 quantity squared. Right? So to get rid of the square, we're going to then take the square root of both sides. You do not need to simplify, or in this case right now, the square root of 12, even though it can be simplified we're eventually going to get a value for d, an actual number value. You should not leave an answer ever, like a final answer, in an unsimplified version. But let's see by the end if that radical 12 is even going to still be in our answer. So this gives us radical 12 is equal to d minus 4 divided by 4. I was a step ahead of myself. And we have to try to solve for d. So our first step is going to be, let's multiply both sides by 4, because that will get rid of the division by 4. So this will give us 4 radical 12 is equal to d minus 4. We can find the value of d by adding 4 to both sides, right? Because that will isolate the d. The d is now alone. And in our calculators, we can do 4 radical 12 plus 4. So 4 radical 12. And then we're adding 4 outside of the radical. Be careful. And we get 17.856, right? And it says estimate the diameter to the nearest inch. So 17.85. This is going to be 18 inches is the average diameter of the log in that shipment. Okay, we're going to skip a little bit and go down to the bottom of the page and talk about 8. The equation for the volume of a cone is given there, where r is the radius in inches, h is the height in inches. We're going to solve this equation for r. So all this means is we're going to try to get r alone. So we're going to take v is equal to 1/3 pi r squared h, and we're going to try to solve for r. So just like a previous problem we've done in this lesson, let's get rid of the 1/3 by multiplying by the reciprocal by 3/1 to both sides. I'll go right here for the lack of space. 3/1 is just 3, so this is 3v is equal to the 1/3 and the 3/1 cancel, pi r squared h. The pi and the h are attached to the r squared through multiplication. It's pi times r squared times h. So to undo that, we're going to divide. We can do it here in one step by pi h. That will get rid of for us the pi, get rid of the h, right? And now we have 3v still going to the right. 3v over pi h is equal to r squared. One final step, we take the square root of both sides to get rid of the squared, and we get r is equal to, and I'm just going to flip the sides here, the square root of 3v over pi h. So this is an equation, right, to solve for a radius of a cone, right? This is to solve for the radius of a cone given the volume and given the height. If you were given the volume of a cone and the height of a cone, you could use this equation to solve for the radius. For example, in B, find the radius. So we're finding r in simplest radical form. So that means that we're not going to have decimals. Of the base of a cone, whose volume is 16 pi, so V is equal to 16 pi, and has a height of 4. H is equal to 4. So let's take that equation. I'm going to rewrite it here. The whole thing's underneath the square root, right? And we're going to plug in those values. So this is 3 times 16 pi divided by pi times 4, right? Plugging in those V and H values. So this will give us, if we simplify 3 times 16, 48 pi over 4 pi. And what's going to happen is the pi's will cancel since we just have multiplication. 48 divided by 4, this is going to give us the square root of 12, which we can simplify because it says simplest radical form, right? We don't want to actually plug in radical 12 and give a decimal. So we can break up the square root of 12 into a perfect square times a non-perfect square. So square root of 4 times the square root of 3 is 2 square root of 3. R, just be careful, R is the radius of the base in inches. So this is 2 square root of 3 inches based off of what the problem asked for. That would be our radius.